So basically you would have heard of this saying that you are the average of the 5 people you spend the most time with, right?
No. What is this?
Okay.
Who is
So
this guy?
not this man, basically, if you but like this saying is like the means like some popular, I don't know why you haven't heard of it, but this is like the scientists also have proved that, I think, means I in the some blogs you may search for it, like you are the
Mm-hmm.
average of the 5 people you spend the most time with, right? Means that you think like
Okay.
of them and you act like them, right?
Ah, okay.
That way,
Oh, okay, okay. Now
in
I
that
catch it.
sense,
Mm-hmm.
in that sense, right?
Mm-hmm. Mm-hmm.
So this algorithm works exactly like that, right?
Mm-hmm. Mm-hmm.
So again, let's take an example to understand this algorithm better. So here we will be taking an example of CGPA and IQ, and on the base of these we will try to predict
Mm-hmm.
whether that particular student will get placed or not. Okay,
Mm-hmm.
so this is your two-dimensional data, right?
Mm-hmm.
And we can do it for multi-dimensional as well, but we are using the is 2D just to do some plotting, okay, so that we can visualize the graph, okay.
Mm-hmm.
And we are suppose we have got this observation, like we got 100 observation or 100 rows for our sample data set, okay. And now we plot that data, right? On the x-axis we have our CGPA, and on the y-axis we have a IQ, right? And this green color specifies your 0 not placed, sorry, 1 that placed,
One. Yeah.
green color, okay. And the orange color specifies not placed, 0. That means if the CGPA is lower and your IQ is also lower, that means that person is not placed, right? If the CGPA is higher and the IQ is also higher, that means the person is green, that means the person is placed, right?
Yes. Mm-hmm.
So basically what we do is we use a Euclidean distance. Suppose we found a new variable, we got an new input variable here, right? Now how you will say that whether this person falls in green or falls in orange, right? So what we'll do is we will basically find the distance between them, all the points. First of all, like we will find the distance from all the points, like 100 points. Like these were 100 data points as a sample data set, and it will find the distance between all the points, this point basically, and then this point, this from each point, right? From these values also, orange also, and from green also. And then what it will do is it will arrange them in the ascending order, or basically sort them and write in the ascending order the distances, right? These 100, the value of these 100 distances. And after sorting them, like you got some values, like after sorting you got 10, this is the nearest element, right? From this, then 12, then 13. These are the nearest, suppose say 3 elements. Now I am using 3, that I have to specify here k nearest neighbors. Here the k is basically the value. It is specify k is equals to something, some value. Like if I say k is equals to 3, it will take the nearest 3 elements.
Okay.
Okay. So this is your hyperparameter. There is no fixed value for k. Like you may choose a 3, 4, or 5, or 6, 9. It depends on the data set and use case. Basically, it depends on the domain knowledge, right? From different data set to different data set, the value changes. For some the data set, the 3 might give some good accuracy, and for some data set 9 might give you the good better accuracy, right? For this value of k. Okay. So if I use 3, so it will basically find the first all the distances from all the points, and then sort them in the ascending order, and then write the first 3 elements. Okay. So it will check for the class of this data set, right? The 10th the element which was having the distance, the least distance, which is this, right? This is your distance at this point. Now it will check which class this data point belonged to. Like this data set, suppose was this green, right? So it will say it is the green one. So green one is your 1, right? So this is your 1. And again this 12, 12 is also suppose say your green one. So this is also your 1, right? Green is 1. And now suppose say the third nearest element is this.
Orange.
Okay, so this is your 0, this. Now what it will do is it will take the majority out of them.
Okay.
This was 1, that means you're placed, that means this also means placed, this means not placed. So it took the majority, like the how the democracy works, right? So it gives the output as 1. That means this particular student has been placed, and that's it. Easy, right?
Okay. Yeah. Combines both.
Yeah. So the it will take the class of the closest point. Like first class was a 1, and the second was also 1. The third was 0, basically not placed, right? Closest one. And then since it took the majority 1, and this is your output. That's it.
Yeah.
And the same applies for multidimensional also, but the calculating distance is a little bit different, right?
Yes. Yeah.
Like you will use some vectors and complex mathematical notations, right? So on the backend it works like that. You plot a value here and you find the distance, you sort them on the ascending order, and then you take some some elements based on the value of k, and you take the majority count.
Okay.
Any questions?
No, this is unrelated. So basically,
Mhm.
in the real time scenario, can you use KNN?
In the real scenario, like example means
KNN. We are using this kind of
Mhm.
thing. I mean, algorithm. This is
algorithm.
KNN
Yeah,
and
yeah, algorithm, right?
algorithm, right? So I when I browse it, I see K linear. I saw a couple of decision as well,
Mm-hmm.
but do we really we will use this one? I mean KNN
This algorithm.
this algorithm. Yes,
Yeah,
yeah, in the
yeah.
real time.
Yes, I will be
Oh, okay.
demonstrating you the code. Okay.
Mm.
So basically, you got the intuition, right? How it works, right?
Yes. Yeah,
Just you
yeah.
have
I
a
got.
parameter, this value of k, and
Yes,
how this
yeah.
is used, right?
Yes. Yeah.
So
From this
now
already. Yeah.
we will be having a code. So here we are using a data set from a Kaggle, and
Yeah,
for doing it,
okay.
we have written some code. You may ignore these two cells, okay? You may just run them and leave them,
Yes, I know.
okay?
Yeah.
And now from here our main thing works, okay? So now we are
Yeah.
loading the data
Very.
set into this df,
Mm-hmm.
okay? So just let me grab some water. My okay. So wait a second, huh? Wait a minute.
Yeah, sure.
Yes. So
Yeah.
the cell has been executed, right?
Mm-hmm.
Let's run it again. And now if I load this data set and run this df.head, I will get the first 5 rows of my column, okay? So this is the data set, right? So it has some values. uh, you don't have to worry about the values, means like the columns.
Yeah.
Just we can see that you may see that your id, right? The values of id and your unnamed. Unnamed is your this column, right? 9 values. unnamed 32. So basically these values are not much important because the ID will just contain your serial numbers, right? So we can just drop them. Okay,
That's a decent draft. Okay.
so we are removing them data set, the those particular columns, and now you can display the data, and your data looks something like this. Okay, and now if you check the shape of your data, it is your 31 columns and your 569 rows.
Number.
Okay,
Yeah.
and now also if you see that we are having some, we have discussed about a topic that is your scaling, right? The example I took, that kg one, like the some values are in
Yes.
kg and some values are in grams.
Yeah.
Then you have to convert all them into one scale, so that our
Yes.
values become in one, right? So if you check the values here, like some values are or on this range, right? And some values are on a higher range, this
Yeah.
value, this value, right? And some are in less than 0 in points. So therefore we have to take care of these values. Like if you take the parameter, you have in 150, and area we have in this, right? So we have to take care of this as well, right? So we will do a scaling on it. Okay, we'll transform these values basically. Okay, so again we are using this train test splitting to split our data to on the train set and testing set for evaluation. Okay, model evaluation. Now if you see the extrain, you will get the 30 column here, 30 column, this another one column is used for your target value, for predicting.
Yeah.
Okay, that will be your target value, that will be stored on your white train. Okay, so basically this extrain dot shape looks like 30 columns. Okay, and your 455, why now rows also are also reduced? Why? Because other rows are used for your, can you,
Test.
yeah, test data set, right? So now here we are performing that scaling the data. We don't have to do anything, we are just using a code here that is your standard scaler. Okay, that comes on your sklearn library. So inside this we will put the data fit dot transform. We are giving this xtrain, and we are also giving the x test. So we have to give the both data set, right? Training set also, test set also. We have to scale them, the both of them. Okay. So now if you see the training train set, now all the values are scaled. They are on the same scale, right? So now we can perform our model easily.
Yes.
Right? Now if you will also check the shape, now there is no changes on the shape because we don't have made any changes. We have just made the changes on the values for every points. Okay. Now here we are creating another model that is your k neighbors classifier. Okay, it basically classifies, okay, between your values. If you will see the white train,